Welcome everyone. Hope you had a good lunch and a good break. This talk is Essential Git for Developers. My name's Adam Culp. You can find me on Twitter at Adam Culp. First name, last name. I speak at a lot of conferences, and I welcome all feedback on any of my talks. So please go out to Joined In after this talk and leave feedback for me. The talk is 14023. I welcome any feedback because I do speak at about 10 to 13 conferences a year, and so I refresh these talks every time I give them, based on feedback that I've received during the talk. So please leave me feedback, good or bad. I welcome both, so that way I can make the talk better for future generations. So a little bit more about me. I'm a PHP 5.3 certified engineer. I work for Zen Technologies. So I do PHP for a living. As a consultant with Zen, I generally go out to companies and help them refactor code, tweak their architecture to make it a little bit better, help them do code ratings to see how the architecture of the code works and everything else. And oftentimes I'm working with developers to tweak their workflows. And I teach Git also on my day job, and teach how to use it in workflows. I'm the organizer of the South Florida PHP user group. We have about 750 members from West Palm Beach down to Miami, Florida. And I'm also the organizer of the Sunshine PHP conference. Similar to this, but it's PHP, and we have about 350 attendees there. It's in February, and there's a lot of worse places you can be in February than Miami. So that's why we decided to have it in February. I'm also a long distance runner. I'm an ultra runner. For those of you who don't know what that is, marathon is 26.2 miles. Ultra means more than. I run more than 26.2 miles. I'm currently I haven't reached 100 miles yet, but I've gotten up to 76. So I have ran 50 miles. I ran 100K, which is about 62 miles. And I stopped at 76 on my way to 100. Just wasn't able to finish, but someday I'll get it. I'm also a black belt judo instructor. I teach judo in Boca Raton, Florida. Now, I bring up some of these things to tell you a little bit about myself, but also to highlight that I'm a big fan of iteration. I love iteration. It's something we do as developers on an ongoing basis. As a long distance runner, I didn't just jump off the couch and say, I'm going to go run 100 miles. It takes training, it takes practice, it takes a lot of learning to understand the nutrition behind it and how to be able to get our bodies to withstand that sort of punishment. Judo, we all know martial arts is a lifelong study to perfect your craft as you get older. Development, avoiding project managers is iterative. We get better at it over time, right? And version control is much the same thing. It is an iterative process. It's something we do over and over and over again. And that's what I hope to highlight here with Git. Git is very iterative. You should commit to your Git repositories a lot. You should do it in very small steps. You shouldn't be committing large bunches of code to your repository at any one given time. You should be a bunch of little commits that make up, one big version. So, why use Git? The beginning of this talk, for about 5 to 10 minutes, I'm going to talk about some of the basics of Git. This is Essential Git. So I'm going to cover some of the base commands and some of the inner workings of Git. I'm not going to get too in-depth. Hopefully it's enough information that beginners will gain some insight. Experienced folks, maybe it might have one or two new things for you, but for the most part it's going to be rehash for people who are experienced. The bulk of this talk is the tail end, which is when I'm going to talk about workflows. That's the thing that I find developers have the most difficulty with, is how do I work Git into my workflow? How do I use Git flow? How do we use branches and feature branches and all this in our day-to-day development? And that's what I'm going to spend most of the time on. But to start with, why use Git? Git, first of all, is not centralized. It's not centralized by nature. You can make it centralized. As we think about Git, most folks are used to SVN or Subversion or CVS or something like that, where you have one main repository on a server somewhere, and all the different developers or people using that repository have to connect to that server to commit code to it, right? Well, Git is not that way, or it doesn't have to be that way. You can make it that way, but it doesn't have to be that way. With Git, generally, you're going to create a repository or clone an existing repository somewhere, like if you wanted it on a main server. And then from there, you're going to use it all locally. You can or cannot push the code to the main server if you wanted to work that way. We'll talk a little bit more about that. But for the most part, it is not centralized. It is on whatever, if I'm doing it here on my laptop, Git is here. I commit my code, I commit it here. I don't have to connect to the server. So if the network's down or the server's down, I don't care. I'm still able to commit code right here. I can get all my commits done without having to connect to the server. Each copy or each repository in Git is a full copy. So on my laptop, I have the same full copy that exists on a server if I'm doing that type of connectivity. I have the full thing here, all the branches, all the tags, all the everything. So it is completely full repository. Git tracks the state of the repository. It tracks all the history and the integrity. It allows you to do branching and merging, and it works. Unlike some other repositories, other version control systems that don't really branch or merge very well at all, Git works quite well. It's very fast. Because Git is local, because I don't need to connect to a server, it's very fast. It's right here. It's as fast as my computer is, right? And there's only one file that houses the database behind the repository. I understand Subversion works that way these days. They fixed it. But it used to be you had a .svn folder in every single folder or directory in the repository. Whereas with Git, you have one .git folder and it manages the whole thing. Another benefit of using Git is you stage your files prior to committing them, and using the add command. We'll talk a little bit more about that in detail. It is free, it's open source, and it has very flexible workflows. You can make Git work in your workflow how you desire it. It doesn't dictate your workflow to you. Some other things to look at when we're looking at version control. The way most version control systems work is they basically create. So when you do a checkout of code, what they do is they say, okay, you want file A? First I have to take this diff, then I have to take this diff, I have to add them together, here's your file. Okay, so it adds them up as it serves you up the file. On the other hand, Git works a little bit differently. So with Git, every single time you do a commit, it creates a full copy of that file. So if I do a commit, I did a commit here of ABC. In version 2, I commit file A, and then I commit file C. File B doesn't change, right? So it creates a full copy of A1 and C1. Now as we continue on, then it's just got a pointer back to here, and this keeps on pointing back. But it's making a full copy. So when you do a checkout or a clone from Git, it doesn't have to add up a bunch of diffs to give you your file. It just gives you the file, whatever the current version is, whatever the current state of that file is, because Git tracks the state of the file. Some general workflows that most people have when it comes to version control, the Subversion style is you have the main shared repository, and then you have a bunch of developers, and the developers pull and push to that main repository. Another type of workflow is an integration manager workflow where you have your blessed repository. The developers pull from the blessed repository. After they change the code and everything, then they push it up to a public area from their private, and then the integration manager pulls it and then pushes it back to the blessed repository. So that is an integration manager workflow. And then we've all seen the dictator type of workflow. It's popular in Linux. It's what's used with the Linux kernel, where you have the blessed repository. All the developers pull from the blessed repository. They push code to the lieutenants. Lieutenants push to the dictator, and the dictator pushes to the blessed repository. So that is the dictator and lieutenants workflow. As a single developer, you have everything. It's just one repository, right? So you're doing everything right there locally, and you only have one copy. Now remember what I said with Git. Git works where every copy, every repository of the code is a full repository. So when you do a Git clone, you have the full repository. Now you might have some pointers to a different repository that you clone, but for all intents and purposes, you have all the versions, all the tags, everything else all right there. So essentially with Git, what you have is you have a repository and you have many other repositories. You don't have a repository and a developer pushing and pulling to a repository. Each one is its own individual repository, and you can push back and forth between all of them, so you can essentially share code much easier. Right, because as you're developing, you can push and pull from any of them. You're not just pushing and pulling to one main one and having to hopscotch everybody else off of it, because it's fully functional that way. Now, very briefly, we're going to go through some different commands with Git, just some entry-level idea things. So we're going to talk a little bit about git config, git init, clone, status, add, commit, log, and show, which are very similar commands, but they show slightly different information. Branch, checkout, merge, and then pull and push, which respectively would do what you're telling them to do, either pull from something or push to something. Now, all the Git commands have an H flag, right? The -H. I'm not going to show a GUI. I'm going to show the command line using Git. There are GUIs available, and we'll talk a little bit about those on a future slide. But so in this case, if I'm saying git add and I put a -H on it, it's going to give me all the possible commands that I can use with git add. So anything you want to do in using Git, you put in the -H and it'll give you the details of that certain command. We also have the config. So when you have a Git repository created locally, or when you install Git on a local machine somewhere, you can set configuration. You can set configuration either per repository or global. There's a lot of different ways you can do it. In this case, I'm saying git config, and I'm telling it to do it global, and I'm telling it to set the username. In this case, I'm setting the username equal to Adam Culp, and then I also do the same thing with the email address, and I set it to my email address. And then if I do a config, git config -L, it's going to list all my configuration items. Those are completely configurable. Now, in the future, when I do, because I set the configuration items here, in future, when I do commits, it's automatically going to assign this to the commit. I'm the person doing it, right? Because I just set this globally. So every repository I use on my machine, it's going to set that username and that email address as the person who did any commits on my machine. So that's something that we set up that way. Using Git is very easy. How many people are using Git? Good, so many hands, nice. How many people aren't? Let's do the reverse. Okay. Now, how many of you use a version control period on every single project that you do? Every single project. Okay, that's good. I'm glad to see so many hands. Usually I don't see so many hands. That's a good sign. We're making headway. The reason I ask that is because with Git it is so easy to use it. All you have to do is git init, and you're using Git. You don't have to jump through any hoops. You don't have to do anything fancy. You just change into the directory that you want to use Git from. You type in git init, and you're using Git. It's just that simple. So there's no excuses not to use it on everything. I version everything that I do, not just development, not just coding and programming. I version pretty much everything. It's not version control doesn't work the best for everything, but I still version everything on the off chance that it might do something good for me. So when we're using a remote repository or any repository, let's say somebody else has code and we want to use that code, right? We use Git Clone. And by using Git Clone, we tell it what repository we want to clone, and we tell it the destination of where we want that clone to be. It's just that simple. And then we have a copy of that code, whatever it might be. Now, inside Git, there's a pointer created, and that pointer now points to wherever you cloned that code from, and you can refer to it as origin. And that's the pointer that's built inside Git from that moment forward. You can change that if you wanted to make some other repository the origin repository. But by default, when you clone a repository, it's going to set origin with the URL or the address or file location of that repository. So an example Git clone would be like this, where we're typing in Git clone, we give it the URL, and then we tell it where we're going to put it, and then it goes through and downloads all the files or pulls all the files and creates it that way. If we do Git Status at this point, Now let's say in this case I did a git init. I didn't actually clone, but doing a git init, anytime we do a git status, it's going to tell you the status. It's going to tell you what branch you're currently working on. It's going to tell you any other commits that are currently there, right? In this case we have just an initial commit. Now if I another thing to notice, if I add some files into Git, right? In this case, I added 3 text files. I haven't actually staged them to be committed to the repository yet, but if I do a Git status after that, we can see there's the first one, and then we can see that there's currently untracked files. They aren't added to Git yet. In order to stage them and get them ready, I have to use the command git add. So I use git add, I tell it the file that I want to be added into the future commit. And if I do a git status now, it tells me I have my initial status, it has files to be committed, and then down here there's additional files that I haven't added yet, so they're not going to be committed. If I did a git commit right now, only the one file would be committed. As I'm doing my commit, I encourage everybody to add a small message with your commit using the -m flag. By adding the -m, then we can put a short message onto it in quotes, and it'll add that message to the commit. We should be adding messages to every single commit. It's searchable, and it also helps future generations understand why you did that commit. You know, if they're searching for something. So the commit message should be nice and short. It shouldn't be a paragraph. It shouldn't be a book, right? You don't want somebody to have to search through a book's worth of text to figure out what happened in every single commit. Your commit should be very small, so that message also should be very small. And people are able to see things much easier. You should do the commits very often, and make your commit message as informative as you can. And very succinct, but as informative as you can. So that way people following behind you will be able to see what's going on. Now after we do our commit, then we can use git log to see previous commits that have happened in the repository. In this case, I've only got one commit message because I've only committed once. If I had multiple commits in the past, they would list them all here. Alternatively, I could also use Git Show. And what Git Show does, if I just type Git Show by itself, it's going to show me the details on the previous commit. However, if I add the hash, the commit hash of a previous commit, it's going to show me the details of that commit specifically. But again, if I don't include the hash, it's going to show me just the previous one. And it's going to show me also a diff, you know, what items were committed in the file, what lines were changed and what have you, as well as the information. So as a git status, we do a git status. We did the commit, and then we can go in and edit some files. We edit some files, so now we have a new file ready to be committed. We're adding some more, and we still have a file that's untracked. The statuses are really actually quite self-explanatory, so don't be afraid of them. When you look at git status, you can read through and figure everything out. I have a couple slides with examples. I'm not going to go into details on those, though. I'm going to kind of skip through those. So now we've got all of our files committed, the 3 files that I created. And after we do that, we can do a git status, and after a git status, we can see, or after our final commit, we can see that they're all done. And we do a git status, we can see that the files, the status of the repo is just telling me I'm on branch. There's nothing else to do there, right? Nothing else to commit because I've committed all the files. One thing to notice is that in Git, it doesn't use version numbers. So version uses version numbers, right? 1, 2, 3, 4, 5. They're sequential. Whereas in Git, instead it uses a commit hash. And that hash is actually your version. Because generally we don't use the version numbers from the version control anyway. And so in order to keep things nice and clear, and because it can be spread across multiple systems, it's important to have this hash so that way it's easier to have uniqueness, right? Because if you had something like Subversion, and if multiple people had multiple copies of the source of the repository, it would be very easy for one person to have a 22 and another person to have a completely different 22. So having the hash separates that out. The hash allows us to have that diversity across multiple copies of a repository. So we use the hash. Now, oftentimes you'll see in GitHub or someplace like that, they might only use like the last 7 digits, because those last 7 digits are unique enough that even without the big long hash, the last 7 characters are pretty much enough to do it. So generally you'll see the last 7 digits used as an identifier. Now, something that we've been doing here, I've gone through examples of creating files, adding them, and doing commits. One thing that I've done here is very bad, and you should never ever do this, and that is stay in the master branch. Do not stay in the master branch. The master branch is that's your golden branch, right? That is by default, when you create a Git repository, the master branch is created for you, and it is your main branch. You should never edit or add or commit anything to the master branch. Never do any changes in the master branch. You should do changes in other branches and then push them back to the master branch, and I'll show you that. And I'll show you the workflow behind that. But you should never do any editing of files in the master branch. There should never be a commit in the master branch. The reason is because we want to keep it bug-free. We want to keep it tested. And the master branch at any point in time you should have the capability of creating a tag off of the master branch and pushing it to production. It should be production ready code in the master branch. It should be, or as close as you can get, right? Now, to kind of highlight this a little bit, if I type the command git branch, it's going to tell me the branches that are available, and it's also going to put a little asterisk in front of the branch I'm currently using. In this case, I only have a master branch, so it's showing me I have a master branch, and it's the one that I'm using. To create new branches, I would use the git branch command, but then I would give it the name of a branch to create. If I wanted it to create off of a certain other branch, then I would also include a second item there, which would be the name of the branch I wanted to create a copy of. If I do not put this branch out here on the end, it's going to make another branch based on the branch that I'm currently checked into. So if I'm using the master branch and I do git branch Adam, it's going to create another branch named Adam, and it's going to be a copy of master branch. And that's how that works. Now, alternatively, I could also do a Git Checkout with a -b and give it the name of the new branch and the name of another branch, and it does exactly the same thing. But what it does is it creates the branch and checks it out all in one step, right? Instead of having to do a Git branch and then turn around and check it out to use it, it does it all in one thing. So then, as I do Git branch, when I do Git branch without a branch name, it's going to basically list the branches for me. And I can see here I now have a development branch and a master branch, and the asterisk is beside master, so I'm currently using that branch. And in order to switch to another branch, we would use Git Checkout, and we're going to check out whatever branch we put after Git Checkout. And now that's going to check out the other branch. And if I do a Git branch now, we see in the asterisk is beside development, because now I just checked out development branch. Right? So we have multiple branches in there. Now, something to note is that each branch is a unique code base as far as Git is concerned, right? If I had a file in my master branch that was different from my development branch, if I check out master, I'm going to see that file in one condition. If I do a check out of development, I'm going to see that file in a completely different condition. I didn't have to change directories in my file system. All I had to do was tell Git to give me a different branch, a different representation, different state of the repository. The file system is automatically updated. So then if you go through the file system and view that file, you're going to view whatever Git tells the file system that it's going to see. So going back a little bit, well, not really going back, but let's say I go in and I change a file. So I do VI, I'm using VI as my editor, and I edit this file, I make some changes to it, and then I do Git Status, and I see here I have changes that are not staged for commit. I haven't done a Git add, right? If you've been following along. I haven't done a Git add, so it's not staged for a commit. Now, it does tell me I'm currently in branch development. So what happens if at this moment I don't commit that file, but I check out master? Can anybody tell me? No, you don't lose it. So what happens is, if I do a checkout of master, it switches to the master branch and brings that unchanged file with it. So now in master branch, I now have the file changed. It hasn't been committed to the repository yet. If I change back to the development, it reverts master. But it's going to continue. That file in an uncommitted state is going to follow me across my branches, right? So just be aware of that. That's caught me a couple times. Right, so be aware of that. The files that are not committed do follow you when you check out other branches. When you commit a file, then it stays there, right? So if let's say that I go back to development. Right now I checked out master. The file followed me. Now I'm going to go back and check out development, and I do a commit, right? So after I do that commit, now my development branch carries that committed file. If I go back and then do a checkout of master is not going to have that committed file, right? Because now it doesn't follow me anymore. It's committed. It's committed into the development branch. Yes?
Only added files follow you, right?
No. Even if you don't add it, it's going to follow you. Yeah. If you add a file, it's going to also follow you, but it's ready for commit when you add it. But yeah, that file is always going to follow you when you switch between branches if it has not been committed.
So like.
Don't overthink it. We can talk more about it later. Let me finish with the talk though. But I can even show you an example of that. But yeah, the file will definitely follow you from branch to branch until you commit it to a certain branch. As I did in this case, I committed it to development. When I check out master now, master is not going to contain that file because it's been committed in a different branch.
Adding and committing.
Think of adding like staging a file for a commit. That's what add does. Add tells Git that file is going to be committed the next time you do a commit. It's putting it there ready to be committed.
Oh, so where a modified one is already there to be committed.
Say that again?
A modified file is already staged because you added it at some point.
No, a modified file has not been staged until you stage it. A modified file is just modified. But it's not ready to be committed until you add it. You need to add it to the staged list to be committed. Now there are flags that you can pass to Git to say ignore adding, just commit everything that I'm telling you to do now. But I recommend doing.
Like if a file is already in my branch and I modify that file, I don't have to react.
You have to add it to your commit. Yes.
You don't add the file to the repository. You just add the changes to the stage.
You're adding it to the change list. Yeah. Yep. All right. So I'd encourage you to test that, play with it, and see. But that's most certainly the way it works. Yes.
What's the reason for having the file follow you from branch to branch?
The reason is because maybe you were editing a file in one branch, and you say, oh, wait, I'm in master. I don't want to commit it to master. Let me check out development. Now it follows you, so now you can commit it in development, which is where you should commit files, not in master, right?
Since none of the changes are actually in there until you stage them, right? What happens?
Until you commit them.
Well,
or sorry, you're talking about staging, okay.
What happens if you check out a branch and then you start making changes, but you don't actually stage it, and then you change branches? What happens to your changes? Are they lost then, or? I don't know that. I don't know that answer. That would be interesting to test. I'm not sure of that answer right now.
I've done that mistake a couple times recently. They follow you just the same.
They follow you the same. Okay. So until they're committed, they do follow you.
You're saying when you check out a different branch, it then overwrites your file system with the content of that branch.
Yes.
So, but
well, only that file. Only that file that hasn't been committed.
But any files that exist that you've modified, do they get overwritten then, or?
They would be overwritten
by the content of that branch?
At that moment, you're right.
Okay.
Yeah, at that moment they would be overwritten, but they're not actually committed, right? So if you revert back to another branch and then commit and then go back, then they're reset back to what they should be. Yeah, let's not spend too much time on that. Okay, please experiment on your own. And if you have any other questions, please catch me after. But I do have to finish the talk in the time we have allotted, please. So, but I do welcome questions. Let's check some of those offline because we can spend all day hashing about that, but experiment with it. The best teacher is going to be experimenting with it and seeing how it works for you. But just be aware that there are gotchas there. So again, if we did the commit first before we checked out master, then the development is going to carry the changes that we made, master's not. That's all that slide's saying. Now after we do those changes, we made the changes to the development branch, but now we want master branch to contain those changes, right? We shouldn't commit into the master branch, but we want master branch to be updated. So once everything's tested, it's good, everything's been blessed, then we want to use Git Merge, and we want to merge those changes into the master branch. So now master is updated according to whatever is in development or whatever the other branch is that you have, right? So we do that, just Git Merge development. Now in this case, we were checked out into master branch, and we're saying merge development branch into the branch that I'm currently in. And that's what this is going to do, and it brings over that file. Now notice here it's also bringing it over as a fast forward. I'll talk about that actually in the next slide. So by default, Git uses what's called fast forward commits. So in Git, using an example, as a typical merge, right? So we have a chain of events that happen here, right? On this second node, we do a checkout, somebody does a checkout, but this branch continues going. Maybe somebody continued editing here. And then they decide at some point, future point, they say, you know what, I want to commit this back to master and merge it over to master, right? So then essentially what happens is it brings it back into master, and then master continues on. So Git will also do what's called, by default, it'll do fast forward. Let's say that we have the master branch, and when somebody does a checkout, they do some code changes, and then they're ready to commit this back to master. Well, if there's not been any changes in this area, Git will just happily move those items over as if they happened in master branch. There's no reason to put the extra little, any other dots there, because nothing happened there, right? So it just fast forwards. It brings it over and sets it right in a line, and that's called a fast forward commit. Now there are flags where you can tell Git not to do that. So then if you use the -no-ff flag, then it would keep that in your representation, so you can see somebody did create a branch and then put it back, right? And you can use that, but just be aware Git does not do that by default. By default, it does fast forward. So sometimes there might be some gotchas there, especially when it comes to rolling back to a previous state, something like that. You just want to be careful with it. Just know that it's there if you ever need it.
I have a question.
Yep.
The no fast forward is just maintain a more clear history of branches you have? Is that?
Well, the fast forward, it basically says, well, you did a checkout, but you didn't commit anything else here, so why should I even know that you did a checkout? It's not important, right? We just continue moving the code forward.
You were on that branch.
Yeah. There's no reason to represent it differently. No reason to keep track of that history. Let's just put it back there where it was. Now, when it does that, all of these, this node, this node, that node, those are all actually put into Git as commits. So when you do a merge from development to staging, or development to master rather, in master it's going to represent that merge as a commit. Just be aware of that. So if you roll back, you want to be aware of you're rolling back to a previous state that might be kind of unstable. So just know about that. In Git, we also have the ability of adding ignores, git ignore, right? And that is a .git ignore file. And generally in the git ignore, people put things in there like their IDE settings, things like that. If you have multiple developers working in the same repository or working in the same code base, I don't need somebody else's IDE settings in my code base. I want my IDE settings in my code base. So you can ignore those files, so that way when they do commits, then those files aren't going to be committed. They won't be added to the repository. There's no reason to have those files in a repository, right? So it keeps the repository clean by putting them in there. Also, another thing that I generally put my password files in there because I don't want my password files committed to the repository. You should not be committing database passwords or any other passwords for that matter in your repository. You should have some way of automating that file so that when somebody does check out that code, then they can automatically create a new password file using some other secure method. You never know when somebody might get their hands on a repository. and then they got your database. They got everything because all your passwords are in there. You should not commit passwords to your repositories. Yes?
Does that file is that housed in the root of the Git?
This file can be housed anywhere within Git. You can have multiple ones. So generally you'll find a git ignore in the root directory, and then you'll find git ignores in some of the subdirectories too, to dictate certain actions within those directories, right? So a prime example, like if I'm using Composer in the case of PHP to manage dependencies and things like that, you can see here I'm ignoring the bin directory within the vendor directory. Because it's going to put, by default, it's going to put all the third-party libraries into vendor directory. But I'm going to keep the bin directory in there. It's just an example. Yes?
If you use a public Git repo, you really want to be careful with passwords. Like on Git, there are robots continuously trolling all new commits looking for things that look like passwords. Exactly.
And there was a few years ago where GitHub actually got hacked, and a lot of passwords went out into the wild, and on private repos and everything else. It was a bad situation. It hasn't happened since then. They fixed those things, but just be aware of whenever you're housing your code somewhere, things can happen, right? I mean, we're all developers, we're all IT people. We know that things happen. So just be aware of that and protect against it. Don't put your password files in your repo. Put them somewhere else. Manage them through other methods. As a PHP developer, I generally use Fing during my provisioning, and Fing will generate my password files for me while I'm provisioning the application or what have you. But that way I'm not storing it in a repository. I'm typing the password in the command line, telling Fing, add this password to that file, and do it through automated methods. So now we'll talk a little bit about working in a team, a little bit more about a team. That's the basics of Git. How do we do that in a team? The way that I work, now I'm going to cover Git flow, and I'm going to cover some of the ways that I do development. Okay, these are opinions. You don't have to use them. If you disagree with them, hold your comments for later, and that's perfectly fine. This is the way that I work. It's the way Git flow works. And if you want to use some other way, that's perfectly okay. Everybody's different. So the way that I generally set up my environments is I set up a testing, a staging, and a master branch, right? Master's by default, it's there. But I generally create a testing and a staging branch. Now those branches, those three branches, never get touched by a developer. Developers never touch testing, staging, and master. Those stay. There's certain people that can touch those branches. It's not developers in my setups. Now I also create a development branch. Developers touch development. And then whenever developers are creating something or they're doing bug fixes or whatever, then they create a feature branch, usually named ticket number -development or their name -development. Those are feature branches, and they build those branches off of the development branch. And then when they're ready to push code back up, then they merge it up, right? They merge from their feature branch to development branch, and then they delete the feature branch. They don't need it anymore. It was only needed for their development, but it allowed them to keep their code nice and clean. So again, no code leaves the feature branch or the development, or no code leaves the feature branch unless it's finished and stable, and then it goes to the development branch, and that's the only branch that developers touch. They don't touch anything else. This means that the merge conflicts happen in the developer's end. It doesn't happen in the QA engineers. It doesn't happen in the provision managers. It doesn't happen in master. The collisions, if there's any conflicts, it happens in the feature branches. Or possibly in development, but usually not in development. Usually it's only going to happen in your feature branch. Now, whenever a developer does a commit, they go through a few different steps. Their commit, they do a Git checkout from development. Now, keep in mind, they're checking out development, and then regularly, they're going to pull from origin development. Now, origin being the main server, right? I'm doing this as if I'm using GitHub or using some centralized Git repository, and all the developers are working off of that, but they still have the local copy of Git. So they check out development, they pull from the origin version of development because maybe another developer pushed something there, right? They need to make sure theirs is updated. This is where conflicts will happen. generally, because they're pulling new stuff in and they're also creating new stuff. That's where the conflicts happen, is right there, as well as in their feature branches. Then they check out their feature branch, they merge from development over, they fix any conflicts if there are any, and then they check out development again, merge from their feature branch, and then they push it to origin. Okay, this sequence of events, it's a lot of steps. This is what keeps the Git repository functioning. This is what keeps the conflicts to a minimum and allows the other branches to all stay clean. So I call this the commit procedure. That's just something that I call it. But I'm gonna mention this a few times as I go through the future slides. Just be aware that they're doing all this. All right, and it's something they do quite often. So now as I showed you the branches earlier, we have some public and some private branches, right? The public branches are the ones that are the development, staging, and master. Those branches are all public. All the developers can see it. All the other people can see it. However, again, the developer should not be committing to anything except for pushing to development. They should use their feature branches. So in a team workflow, a ticket is assigned. A developer is assigned a trouble ticket or a feature, what have you. They, at that point, they do a checkout of development. They create a new branch, a feature branch. And that's where they do all their coding, and they commit very often. They might commit, one time, they might commit 50 times as they're doing their development. After they finish their development, then they're ready to, then they're ready to push the code up. They first do their testing, and then after they do their testing, they merge their feature branch into the development branch. Now, using that the steps that I showed you previous, right? They're doing all their checks and balances there, then they're merging everything to the development branch. That's the developer's workflow. They never touch any other branches. They don't touch staging. They don't touch master or anything like that. They're only pushing to the development branch. After they push there, then it goes to the QA engineer. Now, I realize not every development team has QA engineers. Okay, just go with me with this. But the QA engineer, that's the person who then will do their testing in the development branch. Once they do their testing and the tests do not pass, then they return it to the developer. And this just continues going around. The developer fixes it and pushes back, fixes it and pushes it back until all the tests pass. When the tests pass, then the QA engineer pushes up to staging, to the staging branch. Only the QA person is authorized to push to the staging branch. Everybody else gets their hands slapped. Once it's in staging, okay, then it goes to the deployment manager. The deployment manager at that point does all the regression testing and staging. Now, do you understand the difference between testing and regression testing? Okay, regression testing is when you do testing. Let's say I add a new feature to the application, right? I do testing on that feature. I'm not testing the whole application. I'm testing that feature, right? If the feature works, then we push it to the deployment manager. The deployment manager does regression testing, which means let's test the whole application to make sure that that change didn't break anything else, right? That's regression testing. And that's where that comes in. So now, the regression testing is done there. Now, if the tests do not pass at that point, it doesn't get pushed back to the developer. It doesn't go back to the develop branch. Instead, there's a temporary branch created off of the staging branch. The developer does the work there, and then that branch is merged into the staging branch, regression tested again, until it passes. Now, once that passes, then everything is merged into the master branch. Because at that point it's clean, it's been tested, it's been regression tested, nothing's broken, everything's good. So now it's pushed to the master branch. And then from the master branch, that's where we create our tags. And then the tag is then pushed to production. Right, you push the tag version, not the master, yes?
Do you still use the temp branch approach if it needs to go back to several developers? It's not just one developer needs to do updates to fix the issue, but it has to go back to the team developers.
Well, theoretically, once something is as far as staging, it should never go back to development. That's why you create a temporary branch. Generally, you're not going to have, it's going to be something small by that point, really. I mean, it shouldn't be something major that a lot of developers are going to have to touch. It should be something minor because it's already been tested. It's already been regression tested, so for the most part it should be okay. So you really shouldn't have anything major. If you have something major, then there's something wrong in your development process long before you're getting to this stage, right? So I would say that that should be very minimal. If it does happen, then you have multiple developers create a temporary branch off of staging and then merge it all back. That would be kind of messy. You may end up with some conflicts in those temporary branches. Shouldn't have conflicts in staging at that point. But yeah, I mean, it can be done, but generally you shouldn't have any issues.
What's the difference between a commit with a message and a tag?
So a tag is not a commit. Well, actually a tag is commit the way Git handles everything. Everything's done as commit. So a tag is not actually a change in code. It is just saying code at this stage is version 1.0 or version 2.0. Yeah. Pardon me?
It's more like a branch, isn't it?
No, it's not a branch. It's just a tag based on a commit. So you're saying this hash is tagged this. It's like a short name for that hash.
How do you specify you're doing a tag as opposed to a message?
You actually give it the A, which is like annotate, right? So you're giving it a git tag, you're giving it an annotation, and then you're giving a message with it, so that because it will kind of carry through as a commit within the repository. So you want to do that, and then that tag is what you actually push to production. Now in a single development workflow, it works very similar, where I still, even as a single developer, I will create a feature branch of the development branch, and then I will test it, and then merge back to development. Can anybody tell me why I still do that? I'm a lone developer. Why would I do that?
So you're in the practice.
Nope. The reason, good guess though, but the reason is because let's say I'm a lone developer, the boss comes to me, I got a bug, you got to fix it right now. So I start working on it. I'm working on it in the development branch, right? I didn't do a feature branch. All of a sudden the boss comes back to me, oh wait, we just had another bug pop up. It is urgent. You have to get this one done first. Well, wait a minute, my development branch is completely messed up now, right? Well, yeah, you could do stash, but that's a little bit more advanced than we're getting in here. But so if I had created a feature branch, then I could still create another branch off of development and fix the second bug, merge it back in, merge the code to my other feature branch and do it that way, right? Then my development branch is nice and clean. I can have multiple copies of it. So that's why I still do a feature branch even as a lone developer.
Question on that.
Yep.
You mentioned that if you check out a branch, those changes will follow you. So what if you check out a branch, committed there, and then go back to your dev branch? That would revert back to your previous, right, before you made any commits?
You could do that, but you should have it tested before you push it back into development.
Got
it. Yeah. So again, the same thing here though. Push to development, then I do make sure my test pass, merge it to master, and then I tag it, push to production. So for the most part, it's the same. There's just a few less steps. I'm out of time. But I would still do that and still tag it to push. Just keep in mind you do that. So there's a lot of tools. I got a couple slides to go through real quick. There's a lot of tools, GUI-based tools you want to use. I personally like using IDE-based version control. So whether it's Zen Server or Zen Studio, rather, Eclipse, Aptana, PHP Storm, what have you. There's a lot of different clients for Git. For any operating system, and whether it's Windows, Mac, or Linux. GitHub is a great place to keep code, centralized repositories, have your developers clone it, and then push up to it, so that way you have one central place to keep it all. Very easy to clone from it. You're just putting in the URL and then telling it where to put it on your operating system. So in conclusion, always use source control. Git is a very easy solution. Takes a little bit of learning, but it's an easy solution to use once you get things up and running. Plan your workflow and stick with it. I covered, this is base Git flow here. I didn't do anything different than what is Git flow. There's also a GitHub flow, and there's other flows out there using Git repository. I just covered plain Git flow. You don't have to use this one. You don't have to use any other one, but you should have some sort of workflow and stick to it. And everybody on your team should stick to it. So that way you know how you're going to communicate, how things are supposed to work, and it'll make your development go a lot easier. Plan your workflow and stick to it. Use third-party tools where they're available, and always make sure you do backups. Git is easy to connect to from anywhere. If you want to share locations and things like that, and love iteration. Now, I do have some resources. So this top URL here is where to learn more about Git flow. Also, GitHub has a training.github.com is an excellent place to learn. They have videos. They have even editors and things inside the browser that you can use Git commands and see how it interacts. Bitbucket is another similar to GitHub. And then there's git-scm.com. A great resource for learning there. These slides are already available on my Joined In. So please go out and rate this talk. This is 14.023. Hopefully you learned a good deal. And you can find me on geekyboy.com and also on Twitter at Adam Culp. Thank you.